Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, we have a PC archaeology episode where we're taking a look at a Leading Edge MP-2400L. What's unusual about this machine is that even though Leading Edge was a pretty popular brand, there doesn't seem to be any information at all about this particular computer. It's a 286, it's really big, it's full of cards and hard drives and interesting stuff. And actually, what's better than one Leading Edge MP-2400L, but two Leading Edge MP-2400L? Well, actually, what's better than two? 2.5. I have a bit of a carcass as well that we can take a look at. So with these three machines here, let's take a look inside, see if any of them work, look at what they're all about, and just see what's going on. Because as I said, I Googled and I found nothing about these machines, and I mean nothing. So without further ado, let's get right to it. We'll start with the machine that was on the bottom of the stack. So you'll notice some blue painter's tape on here, and that's because the front panel and actually all the screws are pretty much removed from this thing. I don't really know why someone removed the front panel. You don't need to take this off to get the computer apart. The top metal lid actually removes or has screws on the sides and the back, and then that comes off, leaving this behind, and it's actually firmly attached to the front of the chassis here. Now looking at this front panel, it's a little bit yellowed. The other machine, the one that was in the middle of the stack, actually is the least yellowed of all. Has a key lock right here. We'll take a look at the key in a second because it's kind of interesting. There's that Leading Edge badge. We have a little hole there that's for the reset button, and a hard drive and a power LED. For the drive bays, actually has three 5¼ inch openings, which is one more than the IBM 5170, which this machine is definitely a clone of. Now the middle machine in the stack actually has a blank plate right here to cover up the bottom opening, and is actually form-fitting to this plate here. It has the angle and everything exactly right, so that's kind of cool. And two exposed drive bays is exactly what the IBM 5170 does have. Flipping this plate over gives us an idea of what the original color should have been like. The non-yellowed color would have been this beige that actually pretty much matches the top of the case perfectly. Behind that front bezel, you'll see here that there's another internal 5¼ inch drive bay. It actually has space for two half heights or one full height, which is what's in here right now. We have two floppy drives that are mismatched and an empty bay at the bottom. Now I can see that all of these use drive rails to actually install. So this one has missing drive rails. Obviously there's no way for us to install that third device on this case. And there are little metal plates here that you can unscrew, and that's what holds these drives in. All of these are actually held in on this computer, although on some of the other machines, their drives are kind of loose and floating around. Down here we have a little PCB, and this has the reset switch and the two LEDs for the front panel. We will take a closer look at this key lock in a moment. I have the keys, but they are in one of the other machines, so I don't have them handy. Other things on the front is a speaker grill, and you'll notice here the metal is very thick. And actually that kind of brings me to the whole point that this entire computer is incredibly heavy and really well built. Everything is solid metal and everything is super, super heavy. Now looking around at the back, this machine does have a trim panel. It's made out of plastic and it is quite yellowed, which is why it's that color, but underneath is that thick metal chassis that this whole computer has. Starting over on the left side, we have the power supply here, power switch, not the chunky red one that you have on the IBM systems, but still very satisfying. IEC input, IEC output to hook up to your monitor, cooling fan, and here's the sticker that tells us all about this machine. So as I mentioned in the intro, model number MP-2400L system unit, 115 volts at 6 amps. That's a significant amount of power. There's a serial number there, 400381. So I don't know if that actually started at 4000 or this is a very low sequence number. And the date, December 1985. Also notice right here above the date, says 20 kilograms. I think that's about 44 pounds, which absolutely seems correct. This thing is a beast. I'm not sure I've ever moved around a heavier desktop computer, especially like this thing has two floppy drives and a full height hard drive in it and a bunch of expansion cards. All of that just adds tons of weight. Next up, notice this hole right here actually goes inside the computer. I have a feeling originally there was a battery pack that was on a little carrier that was attached with this one screw, and you could actually service the battery without taking the whole computer apart. Next up, there's the keyboard connector, most likely just a normal AT keyboard. And then we have 10, count them 10, ISA slots. That is by far the most I've ever seen in any normal consumer off-the-shelf type system. Definitely more than the 8 that was included in the IBM 5170 and the 5160 and all those types of machines. The fact that IBM only put 8 slots on their machines pretty much cemented in place that number of slots for every machine after that, all the clone cases and whatnot. Keep in mind that this machine came out in 1985, which is only 1 year after the 5170 came out. So I think this is a pretty early AT clone. Therefore, they probably tried to do some things a little bit different here to, I don't know, differentiate themselves from IBM to make this machine appealing to potential buyers. All right, let's start with this machine by popping the top off and we'll take a look inside. We obviously have 2 other machines, I'm sorry, to look at. And I think these machines are all essentially identical, although it looks like the components that are inside aren't all the same. So there's a little bit of a hodgepodge going on. But let's pop this cover off. Okay, so normally, like I said, the front cover stays on, the plastic trim, and the metal cover on the top actually slots into that. So the way the cover comes off normally is you take the screws off the side, both sides, and then you take the screws off the back, and then this cover simply slides backwards, and then you just lift up on it. Now that the front cover's been removed, take a look at this key switch. When you lock the system, this metal plate actually rotates up towards the top cover and interlocks with it to prevent easy removal of the case. Obviously, with enough force, you could probably get it off. And this switch right here is how the system knows it's in the locked or unlocked position. Most likely, the only function of this is while it's in the down position like it is right now, which is the unlocked position, you can actually type on the keyboard. And it's very typical for these systems that while it's in the up position or the locked position, you can't type on the keyboard. This is very much the same as the key lock here on the IBM 5170 AT. When you lock this, you can't type anymore. And I think this interlocks with the case as well to prevent easy removal. The problem is this entire assembly here holding the lock is just plastic, so I'm sure it would break pretty easily if you needed to force your way into the system. Compared to the Leading Edge, this entire assembly is thick, strong metal, so it's not gonna break that easily. Now with the top cover removed, right away we can see that there are a good number of expansion cards installed in this machine. In fact, there are 7, which would almost max out a regular IBM PC. Although in this machine, because there are so many slots, we still have extra space available for additional expansion cards. We have the chunky full height hard drive, there's the tops of the disk drives, and there is one of the biggest power supplies I have ever seen in a PC. Like, I don't have small hands. This thing, it's really big. And interesting, as I'm noticing here, there's a metal plate right here. Oh, this is the little battery cover that goes on the back. So someone was nice enough to just tape that in. Looks like it's painted metal and would probably match the color of the unyellowed rear plastic trim. Okay, I think the first course of action is to take out these cards one by one, and let's take a look at what they are exactly. So this system uses normal Phillips screws, so nothing Torx or anything like that. And right away I'm noticing that this card is a bit interesting because it actually is a double width card when it comes to the slot cover here. This is giving us a clue as to who actually manufactured this machine. Mitsubishi Electric Corporation, and it's written on all sorts of components inside this machine. So even though it's Leading Edge on the outside, it is absolutely made by Mitsubishi on the inside. Now this actually jives with what we know about Leading Edge, because early on, their machine, the Leading Edge Model M, was an 8088 system, so like an XT class, and it was made by Mitsubishi. In fact, it had a very similar model number to this. I think it was like 1760 or something like that. This is off the top of my memory. There are photographs of the original Model M machine. I don't think it's sold in really big numbers, but it definitely sold enough to have some information about it. But it wasn't long after that M version that the D version was released, the Model D for Daewoo, and that's a Korean company. The Model D was actually a machine I featured on a previous episode of PC Archaeology, so I'll put a link down in the description below if you haven't seen that video. But that machine was just a normal 8088, unlike this computer, which is definitely a 286. Now looking at this board closer, it says subsystem board here, but what gives away what this actually is I'm pretty sure this is a serial board because we have 2 serial UARTs here. These are 16450s. Now the rest of this board is populated with just a ton of TTL logic, even though you might think this is RAM or something like that. These are bus transceivers and whatnot. So I have a feeling this is also a parallel board. If we look here, yes, there we go. We have 2 serial ports and a parallel port. All right, the next board that's installed in this system is a Microsoft Universal Pointing Device Adapter, also known as a bus mouse adapter. And it has the standard bus mouse connector right there, and not a whole lot to say about these. And the next card we have in the system is some type of network adapter, and I wouldn't be surprised if this is like a token ring or something like that. It does say 3Com Corporation. On the back, we have coax and we have a 15-pin AUI connector, so for transceiver. Now the dates on these chips say 1987, but yet the date on the subsystem card and the motherboard do say 1985, which matches that sticker in the back. So this was definitely added after the fact. I like this Sony Statacram chip that's right here with the big Sony branding on it. I noticed down here there's a little neon tube. Almost certainly this is going to be used for some type of surge suppression on the coax line to help prevent damage to the circuits here. I don't really recognize this card. I have to say I've never seen anything like this. So I'll have to look that up and in editing, insert a little extra to say what kind of card this is. And here's the next card in this system. It's an AST Rampage AT. I love the name Rampage. It's a little bit of a pun there. This board is equipped with 256K chips. So 8 of these, well, there's 9 for parity, is 256K. So right away we have 1 megabyte, 2 megabytes of memory. Now, as is typical for these types of cards, there are some switches on the top edge here that allow you to set the card up because you need to tell this card where to start its memory. 286 systems support a maximum of 16 megabytes of RAM, and you can have like 1 megabyte on the motherboard or even 4 megabytes. So a card like this, if the motherboard has 4 megs, this needs to start its additional 2 megs of memory at the 4 meg marker to bring your total memory up to 6 megabytes. I found these boards in the past to be pretty reliable, and there's good documentation, if I recall, about how to set the switches up, because without that, it's pretty much impossible to use these cards. So if you have a RAM card like this, but it's not one of the more famous or well-known brands, it can be very difficult to get it working because there's a lot of switches on here, and to just do it by trial and error would be next to impossible. Next up out of the system, we have a VGA card. This would obviously be an upgrade. This was not installed in this thing when it was new. 1988 date code right there, and 1988 date codes on the ROMs. Western Digital Corporation on the ROMs there, even though it is a Paradise PVGA chip there. Looks like the RAM on here is 4 bits wide. So we have 64K, 128K. This is a total of 256K. And this right here would bring it up to 512K. So a decent card with some capabilities for some extra high-res modes, like with 256 colors in 640K and stuff like that. But on the back plate here, you can see it just has a normal VGA connector and it has some dip switches. And luckily, I think these are relatively well documented, so setting those switches up properly is actually possible. All right, so the next card that's in here is a floppy controller, and it's actually kind of a cool one because it's got an edge connector here, a pin header, another pin header, and on the back, we actually have an external floppy drive connector as well. I think this is a total of 37 pin connector, and it's the same one that IBM used to facilitate external floppy drives on the original XT. The original XT and the original 5150, if you didn't realize, could support up to 4 floppy drives. Now, this is something that really wasn't carried on from the AT on. IBM kind of ditched support for this. But it seems like this card and potentially this system could support up to 4 floppy drives. Now it says copyright 1987, Micro Solutions Incorporated, and the Compata card. Now, I'm curious what the original floppy drive controller was in this system, because clearly this was not that. Maybe one of the other systems has it still. And we are down to the last card in this system. So this is a Western Digital MFM hard drive controller, the WD1003-WAH. I've definitely had some of these in the basement before. They're very good cards. They're very reliable. There's 1986 date code on that chip. There's some other ones that are 85, so this seems to be an early 86 card. 16-bit card, of course, means that this needs to work in an AT because this does not have its own BIOS on it, even though there's a little bit of a sticker right there. That means that you have to use the onboard BIOS on the motherboard to set up the hard drive type, which is how IBM did it on the 5170. So this is really just sort of a copy of that original card. Well, that card on the IBM had a floppy controller on it as well. This card copies the entire command set that IBM standardized on their card for AT cards, and then the floppy drive controller is obviously separate. Now, one thing about MFM hard drives, you can just see the hard drive right there, you have to be aware of, is that often you need to be matched to the right controller for the data to be read off the hard drive. Not to mention the heads and cylinders have to be correct as well. These don't have the sector translation of newer IDE drives, so they're not forgiving if you don't have the heads and cylinders right. You got to get that pretty much exactly right. Now, I found typically on ATs, when you're using 16-bit cards, all these cards are pretty much the same. Like, they're all a copy of that IBM original card that came out in the 5170. So these generally work interchangeably. It's with the XT that things are much more, well, let's just say not compatible with each other. So if you have a working hard drive in an XT and you plug it into this controller, you're not going to necessarily be able to read the data, and you have to low level the hard drive first before you can use it, and you'll lose any access to that data that might have been on there. I think what I'm going to do next is just remove the hard drives and the floppy drives from the system. It's going to make it a little easier to handle because it won't be quite so heavy. These are the little plates that this system uses to hold the drive rails in, while it keeps the drives from sliding out of the machine. And the design is kind of cool because all you have to do is loosen the screw and they actually kind of tilt downwards. You don't have to take them off the machine entirely like I just did. And that allows you to take the drives out easily without misplacing these little metal plates. Because frankly, that was a common issue on a lot of these systems that use these little retaining clips. If you took them off and just misplaced them, then the stuff would just slide around in the case and it wasn't ideal. So I'm gonna put this one back on there. So they're all on there now, they're just turned sideways. Now there's a good chance that this hard drive is not parked, so I'm gonna be very careful with it. In fact, I don't even know how these machines were handled before I got it. They probably were banged around quite a bit. On the top here, flag track logs. This is the bad heads and cylinders, and at some point, someone added an extra one there. So you low level the drive and it would tell you, oh, you have some bad sectors. You just type those in. That way DOS wouldn't even have to see those. They would be kind of marked out, I guess, in the partition table or whatnot before DOS even tried to format it. Now here's something that's interesting. This has a compact sticker on it. So this obviously came out of a compact original. And it's a Magnetic Peripherals Incorporated hard drive, which was a controlled data corporation out of Oklahoma City, Oklahoma. And I'm noticing here the Type 12 sticker, someone crossed that out and wrote 14 on it. So we'll have to try 14 first to see if we can even read this. That's, of course, if this drive even spins up. Let's slide out this floppy drive here. I've unconnected the cables on the back. There's the drive rail that this system uses. Pretty run-of-the-mill. I think any drive rail for any type of AT type system, which is a good thing because I actually have a STL file I can 3D print if I need to make more of these, if I want to max this thing out with more disk drives. Looks like here under the drive rail we have a Mitsubishi sticker, so this would be the original floppy drive that was on this system. So that's interesting. A black drive would have been what came with this, even though it has a whole beige color scheme going on. I can't make out the model number of this drive because it's covered up by the drive rail, but I would say this is almost certainly going to be an 80 track drive, so 1.2 megabyte, and it moves freely, so there's a good chance this drive works perfectly. And let's slide out this second drive here, and this drive says Toshiba Corporation 6882E1J. I don't recognize that model number. I don't really know these Toshiba drives that well. And here's the floppy drive. It's a floppy drive. It probably works. These things are dead reliable. 1.2 megabytes on this one. Let's take out this power supply because we're gonna have to take a look inside and see the condition of it, not to mention try to do a little testing on it first. Don't necessarily trust it to work right off the bat and not damage the motherboard, although I suppose if it does, we still have 2 other power supplies and 2 other motherboards that we can test with, but you know, I'd rather not sacrifice a motherboard if I don't need to. Now, one thing I can definitely tell, I know we haven't taken a close look at this yet, is that this motherboard is not a standard AT motherboard. Therefore, this motherboard's not gonna work in any other case, and a regular AT motherboard is not gonna work in this case. Looks like this case can only accommodate this motherboard and this power supply. This power supply is also very, very non-standard. And the reason why I say that is take a look at the power connectors on the motherboard here. This looks almost like an Apple II connector of some kind. Yeah, this is very similar to an Apple II style power supply connector. And then it has an additional connector here, and this would be for the additional voltages that are carried to the motherboard, especially to the ISA slots. This one here is almost certainly 5 volts and ground, which is why it's red and black. But ISA slots get 12 volts, minus 12, and minus 5 volts as well, which is almost certainly what's carried over this connector right here. So we get a total of 4 Molex connectors on this thing, which is not very generous considering there are actually 5 bays there. You figure there should be at least 1 for each one of the bays, but I guess they expect you to use a splitter. And look at this, after I removed the ribbon cables, I'm noticing that this actually has onboard floppy controller on the motherboard. Perhaps the onboard controller on this thing has gone bad and they were able to disable it and switch to that expansion card. So to get the power supply out, it appears to slide forward. Now they took the screws out and then it comes out. So there it is. This is what I'm talking about, it being a little bit non-standard. With this big overhang going on right here. Now the original IBM 5170 also had a similar design. The proportions are a little bit different, but the overhang on the 5170 is a lot smaller. And a lot of AT cases after the 5170, they copied the way IBM did it exactly. They didn't kind of do their own thing like Mitsubishi did with this thing. On the side of the power supply here, it says PC13WA, and then it has the output voltages, which as we expected, 5 volts, minus 5, plus 12, minus 12, the usual stuff. I like how Mitsubishi wrote 3 kilograms right on here, like, hey, by the way, yeah, it is a really, really heavy power supply. Here we are taking a look inside the power supply. It's a multi-board design. It's also upside down. The top is this part on the bottom here. The cover comes off really easily. You just take the screws off and it just slides off. This top board here seems to be the mains input and the high voltage DC generation. So this takes the mains input and it rectifies it and then puts it through these large capacitors right here. So that turns into like 300 volts DC here in North America, or 260 or whatever it is. And that sends it down to this board here, where it's converted then into the regular DC voltages, which works like a pretty run-of-the-mill power supply. I see Nichicon caps on here. This thing would be early 80s, so these are gonna be top quality, like really good quality caps. I don't see any refas. I can see there's some filter caps over there. They're the type that generally don't go bang like the refas do, but they can get leaky, which can cause your GFIs or your RCD breakers to trip. Depends on how they're configured. So if that happens, I'll have to take this apart and get those out of there and replace them with something a little bit more modern and a little more safety appropriate. But right there, that's the bridge rectifier. So yeah, pretty interesting power supply, but everything looks pretty good in here and looks very high quality. So I don't think this thing is gonna have any problems. In fact, check this design out. This is the high side, that's the low side. We have a really nice separation distance here with a little mark there. And then we have all this extra stuff here for extra current capacity. That's pretty cool. For loading this things up, I'm going to use a couple light bulbs here, and this thing can do 23 amps at 5 volts. So that should be no problem at all. I'm going to use 4 nails total to try to avoid the problem I had last time when we were testing the Apple II power supply, where the nails were getting hot and I was getting that voltage drop. All right, everything's connected. I have the multimeter over here. I'm going to turn this on. No breaker tripped or anything like that. The power supply is off. The switch is off right there. So let's turn this on and see what happens. All right, we're getting 5.15 volts on the 5 volt rail. Let's check the 12 volt rail using this multimeter here. We're getting 11.9. Is that readable? Yes, it is. 11.9. Okay, so that's okay. I'd like to try to bring the 5 volt down a little bit. 5.14, a little too high for my liking. I can see a potentiometer right here, and I have this ceramic adjustment tool, so it's completely non-metallic. And we're gonna see if we can get in there and tweak this. Oh yeah, that worked. So that is totally changing the voltage there. So we're at 5.06 now, 5.15. Let's just turn it down a little bit. How about 5.07? Seems like a happy medium right there. And we have plenty of load on this power supply right now. I let the power supply run for about 10 minutes with a hard drive hooked up to it and those light bulbs, and nothing bad happened. So I gave it a dusting, cleaned out the inside, and put it back together. Now let's turn our attention back to the chassis here. You might be noticing that there's a blank on here now. Well, I was looking around the case and it was actually just stuck down here behind the slot brackets here. And I pulled it out and it looks like it fit on the front. So with that attached to the front, let's see if this actually works. I think it does. All right, so that's kind of cool. I wonder why the other computer has a plastic blanking plate that goes into these little notches here on the front bezel, as opposed to something that's metal that you screw in. But hey, that's better than nothing, isn't it? Now, incidentally, taking the faceplate down, it has these hinges that go along the front that go into the metal chassis, and one of them is broken off, but just one of them. And it definitely does get screwed into the front chassis, so that should hold it on with no problem. In addition to the front blanking plate that I found, I also found this, which was another set of the keys that go with this machine. Now, I said I already had one set, and I did notice that they actually are interchangeable. So the one set that I did already have worked in all 3 of the machines. But now that I have another set of these keys, take a look at the key. It actually is half decent. And when you put it in there, it has a nice firm positive action. And there's that mechanism that latches the top cover, as I talked about earlier in the video. And you can pull this out so you can leave this locked and take your key with you, and then someone shouldn't be able to use your computer nor take the top off till you come back, close that down, and then you're good to go. This is really what I wanted to show off. Take a look at this motherboard. We have 1 meg of RAM, and it looks like it came with 512K, and then we have an additional 1 megabyte. And then there are those 10 ISA slots. Now we actually only have 9 installed in the board, but you can see that there's a footprint for an additional slot. So you could have all 10, and all 10 of them can also be 16-bit ISA slots. Right here we have the 286 processor. This is the type of package where it's a little flat ceramic package with gold contacts, and it's held down by this metal little cover here. We do have a Mathco processor, and this is the -8 variant, so I think that means 8 megahertz. You should be able to get a look at the unusual power connector and the other power connector here that goes to that proprietary power supply. And then take a look at the battery on this thing. I think that little metal cover that I talked about wasn't actually for a battery holder or anything like that. It looks like it was to access some dip switches right down there. Those are the dip switches. So that's the cover right there. And now you can actually access these switches. But I think we really lucked out with these batteries, because if I pull this thing off the motherboard here, sealed NiCad battery, 3.6 volts, 150 milliamps, Japan Storage Battery Company. This could have been really ugly, and luckily it wasn't. Nothing leaked on this battery, and I just quickly looked at the other machines, and they hadn't leaked either. So how good is that? This could have been very, very destructive for this machine. What I did do is I chopped off the cable from that battery because it's a little bit of a non-standard connector. So I'll just leave this plugged in the motherboard until we're ready to connect up another battery. This motherboard has some jumpers, like here's a few right here, but unfortunately there's going to be no way to figure out what they do because there's just no documentation, at least for the leading edge version of this thing. And moving back to this part of the motherboard, there's a few more jumpers. We have a bunch of GALs or PALs or something like that. So these are custom chips, and if they're dead, the motherboard is definitely not going to work. Luckily, I think we have enough parts here to at least make 2 fully functional machines, and I think the extra machine will just be parts because that carcass machine never had a lid or front panel or anything like that with it. Over here, as I mentioned, the onboard floppy controller lives. We do have some bodge wires, by the way, that make their way around the board. But for hardware configuration options like the floppy drive controller, it's almost certain you have to set these switches to enable or disable this. You're not really gonna be able to see very well, but down there is the floppy drive controller to 765, which is a very standard part for the PC. This computer just appears to be a really well-built, but yet somewhat customized IBM PC-AT clone. Well, I mean, to be honest, for all we know, this isn't even fully PC compatible. I guess we'll find out when we try to actually get it booted. But the fact is that it has regular ISA slots and it has normal PC style cards in those slots that we just took out, like a VGA card. Makes me believe that this thing is going to be 100% compatible. There, the BIOS is really going to be the main part with the IBM PC. One little tidbit I want to mention about this machine, I noticed when I went to put this faceplate on here, is that the screws on this thing are entirely metric. That is completely different than IBM, who use imperial threads. And to this day, every single PC case you buy, when you go to like screw a card in or whatever, is entirely using those same threads as the very first IBM PC, the 5150 from 1981. So that means if you get one of these, don't just use an imperial thread and jam it in there, just get the right metric screws and you'll be good to go. I have talked long enough. It is now time for some testing. The power supply is back in the machine. I took the computer outside before I put the power supply in, gave it a little air dusting so it's a bit cleaner. Although if, well, this thing is still very dusty inside, it would need a proper wash. We're gonna be using my post analyzer card here just to see if this thing works. I'm not fully expecting this BIOS here that's on here to actually support postcode. So if this doesn't show anything, that doesn't necessarily mean it's not working, but we should be able to see some activity here with the LEDs. And I have the power connected to the power supply, and here we go. Okay. We're not getting any beep codes. Of course, we're not seeing any post codes, but that might be okay. I would expect to hear, ah, yes. There's signs of life, everyone. We have beep codes. Definitely the postcode analyzer is not helpful when it comes to the display there, but at least the LEDs show we have good power rails. And let's hit the reset button. There we go. That's normal for reset. You get one LED off, another one on, and we let go, and I think it's gonna give that same error again. There it is, came much quicker that time. All right, this is a great sign. I'm gonna get the VGA card, we're gonna grab a monitor and hopefully see this thing come to life. And let's see if we get an image. It initialized, it appeared to initialize. Oh, it says RAM R test, okay. FDD test. CMOS power failure, continue, press F1. You probably can't read any of that. All right, this thing appears to be working. Unfreaking believable. All right, so let's put in the XT IDE. That's exactly why I have cards like this, because you don't need to go to the CMOS settings or do anything to get the system to boot off of it. Card is in. Let's see if it works now. Hopefully that is readable on the camera. It says F1 to continue. Oh yes, all right. This is a good sign, everyone. Let's see how fast this computer is. The BIOS manufacturer says Mitsubishi. did they actually reverse engineer their own BIOS, or was this somehow licensed from IBM or something like that? So there it is, 8286 AT machine, A20 is active. We have an 8287 math coprocessor, 512K of RAM. It somehow thinks we have 13,000K of extended memory. So that's just a corrupted BIOS that's doing that. And this is what we all want to know. How fast is this computer? I'm predicting 8 megahertz, 8.01 megahertz, 1493 dry stones. And then the math speed is 263,000 whetstones, or 40 times that of the IBM PC XT. Let's run the landmark speed test here, see how many wait states we're running at. 8.9 megahertz. So I'm going to say this has the exact same wait state configuration, which I think is 1 wait state, as the original IBM PC AT. If this thing were running at 0 wait state somehow, if it had very fast RAM or whatever, then we would be getting more like 11 megahertz or so. It makes sense that's not the case though, because this thing was from 1985, which is only 1 year after the IBM PC AT came out. And in fact, remember that the original PC AT was only 6 megahertz. I'm not sure when the 8 megahertz version of it came out, but this thing from 1985 was already faster than the original PC AT, and 1 megabyte was possible on the motherboard, while the original PC AT, 512K was the maximum that it ever had on the motherboard. Now it is unusual though, because it is showing that we have only 512K of RAM and definitely 1 megabyte is installed on the motherboard. But I'm assuming the configuration of this thing right now, and this is kind of unfortunate because of the way that the dip switches and stuff are, we don't know how they work. It's currently probably set for 512K and conventional memory, and then the rest on the motherboard here, the other 512K, is probably extended memory, which is in the higher bank. Usually, well, on clone motherboards, there are ways to configure it where your conventional memory is 640K and then the little 384 is extended memory. I'm going to move over to one of the other machines, but before we do that, we are just going to take a picture of the dip switches on this machine and the jumpers that are in here and back here as well. So I have a record of the way this one looks compared to this machine, which, as you can see, has been stripped for all of its cards. It just has the original Mitsubishi dual serial parallel card. And on this machine, there is no floppy cable over here, which means it must be using the onboard floppy controller. So that's a good thing. These are just hard drive cables. And this is what I was talking about, that faceplate on this front panel. Notice it's actually in the plastic and there's no metal one behind there. So it looks a little bit better because it matches the lines of this case. This one's also a lot less yellow than that other one we were just looking at. Although it definitely has some yellowing, it is much less. Interesting that this one has a beige disk drive on the top. I'm gonna get this front panel off so we can slide this out and the hard drive to take a closer look. All right, faceplate is off. There were 3 screws along the top holding it on, and they are plastic type screws, not some kind of metal insert metric ones. We can definitely see that this one is yellowed a lot less because there's a little bit of yellowing, but compared to the inside, it looks basically the same. I'm intrigued that this has a metal cover over the hard drive front. Must be a shielding thing, I'm presuming. Whoa, okay. Underneath there is a full-on faceplate, and I guess this cover is actually what holds this in place. The cables have been freed, and let's slide this thing out of here. Whoa, heavy beast. It says Type 3 cylinders were written on there. This is model number CM6640s from Computer Memories, Inc. Okay, here's the floppy drive. This one is a Fujitsu Limited drive, model number M2553K. So I don't know if that's 1.2 or 360, but I am assuming it is. Oh, look, 96 track per inch. Okay, 12/1989. So someone was doing testing on this at some point. That's pretty cool. Looking inside the computer here, we have a mega amount of dust. That's kind of gross. Although overall, it's less dusty when it comes to that fine dust that was on the other one. And other tidbits about this: no math coprocessor. Everything else looks the same in here though. I am going to take a picture of the switches and the jumpers just like I did on the last one. Here's something interesting. The manufacture date on this is July 1986 and the serial number is 001020. The other one started with a 4 if I recall, the serial number that is, and manufacturing date was in 1985. Looking at the dip switches on these two machines, they are configured differently. All the jumpers on the motherboard are the same, but the dip switches are different. That's a good sign. I'll make sure to document this. And here is our final machine. This is the carcass machine that I had on the top of the stack at the intro. This one has 2 hard drives in it, and this black floppy drive, which I'm assuming is the original Mitsubishi one. It also has a somewhat full complement of cards, although not exactly the same. So let's take a look at what's different here. On the back, things are similar to that first machine, 400227 and a manufacture date of December 1985. And I think the main difference is this looks like an EGA card that's installed in here as opposed to a VGA card, and we have a different RAM multi-IO type expansion card installed here. I also have the keys. They were stuck inside this computer, and if we take these out, we have S727 on the left, and then we have the X key on the right, the one I found taped inside that other machine. All right, so let's try this key. This is the X key here. Oh no, it does not work in this. Let's try the other one on the key ring here, which I'm assuming is the same. Nope. And then these are the ones that were in the little bag that I had in this computer, but nope, that does not go with this machine either. Well, here are the other two machines, and let's see which of these work in which machine. So that doesn't work in there. That works fine in that one. And this one, I presume, is going to work in this one. And yep, it does. Okay, so two of the machines have working keys, which is good because this is the carcass machine that's missing the top cover and the front cover and was never going to make a working machine anyways. So it's good to have the right keys for the two machines that can be put back together. All right, so first card out of the carcass machine, we have a Genoa. Ooh, I haven't seen Genoa in a while. EGA card. Well, this has 256K of RAM, Genoa BIOS 3.0-5, and there are the dip switches. Up, down, up, up, up. However that is configured, I don't know. I'll have to go look that up. Ooh, and next up, we have an Intel RAM board. So we have memory here, which I'm assuming these are 256K chips, so that gives us a total of 1.5 megs of RAM, and then there is a serial UART, a 16450 again, which looking on the back of the card, there's a serial port and a parallel port. And then we have some dip switches, which are going to be for the memory configuration of the system once again. And next up, we have an MFM controller, and this has date codes mostly from 85, although this chip here is 5th week of 86. So my assumption is this was installed in the machine very early on when this thing added hard drives or had hard drives added to it. And you'll notice here by these cables, this has two hard drives in it, which you can actually see. There's one right there and another one right there. We have another cable that was floating inside the machine. This is a floppy drive cable, and judging by the short length of this and the folds, this is definitely the one that was originally attached to the motherboard. It is no longer attached. We have a nice ceramic math coprocessor, the 286 chip there. The BIOS looks the same, and we have 1 meg of RAM installed on the motherboard along with this serial board that's in all three of these machines. And incidentally, the math coprocessor in here is a -3 variant, which I'm pretty sure is the one that runs at like 4 megahertz or something like that, or half the clock speed of the system clock. Let's get these hard drives out of here. So this first one, oh, I've seen this before. It's a half-height control data or magnetic corporation, the same as that full-height one we had on the other machine. I'm pretty sure I have a drive exactly like this, and I can't remember if it works or not, but I think it does. And what reminds me about it is it's got this plastic cover on the bottom, just a sheet of plastic. And does this have original drive rails? I don't know, these look like they're some kind of resin. Kind of interesting. And the floppy drive, which already had the cable removed. This looks like definitely one of those Mitsubishi drives. Let's get this grounding cable off of there. And indeed it is. It has the Mitsubishi sticker right there. And that looks like the original drive rail for this machine because it matches what was on the other machine. And this hard drive here is being very stubborn with the power connector. We have a message here. It says good 40 megabytes, originally from Andy's PC and formatted for 30 megabytes. Wonder what that's all about. Fujitsu Limited M2553K. That's the actual true part number on this thing. All right, looks like my camera's about to overheat, so I'm gonna let it rest a little bit while I clean up a little. So what you see on the bench here are all of the parts that I took out of all three of the machines. The motherboards were left in the two machines that are complete, but I did fully disassemble the carcass machine. Here's the motherboard from it, and I have the heavy case here that held it all, and even though it's empty, yeah, that weighs quite a bit. I even went ahead and removed the back panel from the carcass machine. This was the only part of the trim that I had left from it. Unfortunately, a bunch of the clips broke in that process, but at least I could use that on another one of the machines, maybe with a little bit of glue or something, if it's better condition than the ones that are on the other computers. Because this video is getting pretty long, I've decided to go ahead and test all these components off camera or on a second channel video. I think I'll put testing these hard drives on a second channel video, so if you're interested in seeing that, definitely watch for it, or if it's already out by the time this video comes out, I'll have a link down in the description below for that. What I want to do is take the best components from what we have here on the bench and make one really nice Leading Edge MP-2400L machine and show it fully operational and working. So it is time for a jump cut while I go and test all these parts. And yes, another wardrobe change. This particular project with these Leading Edge machines is taking me a really long time to complete. I think I'm pretty much over the hump and we're ready to finish up the machine now. I tested all the hard drives on a second channel video, so I won't really talk about that. You go watch that video if you want to see what it was like testing out those hard drives and what the result was. But I can tell you that I have one working drive that I'm going to be using in the computer today that I put together. When it comes to all the other hardware, there were 4 disk drives and motherboards and power supplies and all that other stuff. Everything worked. Every single thing that I tested worked perfectly. There wasn't even a single bad RAM chip on those RAM cards we just took out of the computer. I'm actually, frankly, kind of shocked. What I have on the bench in front of me here is one of the motherboards I took out of the carcass machine, so we can take a really nice close-up look at this motherboard, because it's kind of a weird one-off configuration. Like I said, it's only going to work in these computers, so you may never see something like this again. And this is it, the motherboard from the Leading Edge MP-2400L in all of its large glory. So as I mentioned earlier, we have 10 slots here, and even though that one's not installed because it has that double width serial parallel card, you could easily clear out those holes here and install these extra bits and have 10 16-bit ISA slots. I actually did a bunch of testing with this motherboard to figure out how the dip switches work, and I have that little chart right here, and I'll get to that in a second. The machine obviously has 1 megabyte of memory here that could be configured in a couple different ways, and we'll talk about that. The BIOS chips that are in here are just these 2, and I have dumped those BIOSes, so I'll make those available for anyone who wants to check out this Mitsubishi BIOS. There are jumpers on the board right here, just like between 27256s and 27128s. So I guess that allows you to have a larger BIOS if so desired. These chips here, though, are 27128s, and we obviously have 2 additional sockets available for an enlarged BIOS, maybe one that could support proper menus and things like that. In case you're not familiar, it is very typical for 286 motherboards to have 2 BIOS chips like this, and it's really because this is a 16-bit processor. It's right under there, and these are 8-bit chips, so you really need 2 of these to work properly on a 286. Now, in case you haven't seen these types of sockets before, these Text Tools 3M sockets, you can actually release the CPU by sliding this backwards. Oh, it's really stiff there, and there we go, it pops up. And there is the actual 286 chip in there. It's a ceramic flip package, I think it's called. There it is. It's quite a beautiful package, actually. The gold and everything, and ceramic on this side. This is an actual Intel part as well. And to get the chip back in, you have to position it on the socket. And I think we have to get this like that. And then slide this back, and it's... there we go, like that. That holds it in place, and it acts as a little bit of a heat sink as well. These chips do run pretty warm. Now back on the rest of the motherboard, I think this is a very typical chipset for the 286. We have like 2 DMA controllers, 2 IRQ controllers that are cascaded together. I think that's these and these. Over here we have the floppy drive controller, and incidentally, remember we had that one computer that had an external floppy drive controller, or sorry, it was an expansion card. I don't know what was going on with that, because all 4 or all 3 of these motherboards have a working floppy drive section. They all just work, and I'm actually not even sure how to bypass the floppy drive controller. I think what was happening was this additional card that was in one of the machines is acting like a secondary floppy drive controller. It's designed for XTs only when I look this up, so it can only do 250 kilobit per second floppy drives. That's like a 360 or 720s. So my assumption is the internal floppy drive controller, well, it supports A and B drive, and maybe they were using the C and D drives with this, or perhaps it was connected to a tape drive solution. Don't quite know. At the top of the motherboard, we have the battery connection. It connects right here. There's the little wires that are left behind. This is very typical that it does try to charge the battery. So if you're going to try to hook a battery up to this, you need to use a diode. There are some jumpers up here, and I don't quite know what those do. I couldn't really figure it out. Basically, this is always seemingly getting the 5 volts while the system is powered up, and I did try changing this jumper. That doesn't seem to do anything different. This is the clock controller chip though, so you could remove this and replace it with one of those integrated clock chips that has its own battery, kind of like a Dallas chip. I had a video on my second channel about my AT5170 where I did that mod, which helps make the battery last a lot longer, because typically these types of solutions with the battery connected here will drain the battery relatively quickly. So I do recommend, if you have one of these, swap that out for one of the Necroware clock chips. These are the dip switches right here. I'll talk about that in a second. And like the rest of the stuff on here is just pretty much standard TTL logic. It's just a motherboard that is a clone of the 5170's architecture, which is just basically the XT architecture extended for double the number of IRQs, 16-bit slots, and double the number of DMA channels facilitated by cascading these chips together here. And Mitsubishi just went the extra mile to add up to a meg of RAM on the motherboard and a floppy drive controller, plus some extra other small capabilities of this that are over and above better than the IBM. If they had just used the standard form factor that IBM originated though, like with a built-in keyboard connection, then it would have been possible to put this motherboard into an AT or put 386 motherboards into that large MP-2400L case, for instance. But unfortunately, as I mentioned, this thing is totally custom, and this is the only motherboard that's really going to work in that case. Now let's talk about the dip switches. I did go ahead and basically compare the dip switch settings, which are right here on all three of the motherboards that I worked on, and I tried to figure out what all the dip switches did. And I did that by using actually this motherboard on the bench over there, plugged into a power supply, of course, so I could start fiddling with the settings on here more easily than having it in the case. And I actually was able to uncover some neat and interesting features about this motherboard, but also some limitations. Now, right off the bat, one interesting observation I was able to figure out is that the RAM is actually configurable in two different ways. One way is with 512K of conventional memory and 512K of extended memory. If you take a look at dip switch 3, it was on all three of these motherboards, and I represent X with on. I know it's a little weird, and the O is off. So on. Well, it turns out when this dip switch is in the on position, it sets up the motherboard with the 512K of conventional memory right here and 512K of extended memory. Well, the other configuration of dip switch 3 is in off, and what that does is it configures the RAM for 640K of conventional memory and no extended memory. My thought is that with this motherboard right here, 256K by 1 chips are installed in all four of these banks. Well, it's actually two banks because it's a 16-bit processor. So this is bank 0 and that's bank 1. Well, in the 640K configuration, I think what's happening is that this bank is configured with 256K chips, and then this bank here, the second bank, is configured with 64K chips, which gives you a total of 128K in this memory. Now, initially I thought when I set it for 640K that the other unused part of this memory here would be available as extended memory, so you'd have 384K of extended memory. That doesn't seem to be the case. When you have dip switch 3 set for 640K, you just always have 640K and that's it. You have no extended memory. 64K chips are actually the same footprint, and there's just one extra unused pin. So I have a feeling flipping that switch just ignores the extra address line on these chips and just uses them as 64K, which results in no extended memory on your 286. It's not actually a big deal that we don't have that extended memory. And yeah, it's a little bit of a waste, and I think back in the day you would have been throwing money away by putting 256K chips in here. But nowadays it's not that big a deal, and we can just use one of those ISA RAM cards to extend the memory the rest of the way. But I actually figured out some other interesting tidbits about this motherboard that actually make it quite a bit faster than the regular 5170. One thing about the 5170 is that it runs at either 6 or 8 megahertz depending on which version of the motherboard you have, and it always runs at 1 wait state. That means that the performance is, pretty good, but we know that when you run a 286 at 0 wait states, that means the processor is not waiting around for the memory to become ready or other components on the board, you get a significant performance increase. Well, it turns out that this motherboard, via those dip switches, has 2 different clock speeds, well actually 3 different clock speeds available, and either 0 or 1 wait state. And it has to do with switch 1 and 2, where there are 4 possible combinations, and I've outlined them right here. So the first configuration is when 1 and 2 are both on, you get an 8 megahertz system with 1 wait state. It's very similar to the 5170 at 8 megahertz, the later versions of the motherboards. And there's another configuration where 1 and 2 are both off that gives you 6 megahertz at 1 wait state as well, which is exactly like the earlier 5170 motherboards. If you change switch 1 to on and then 2 is still off, you get a 6 megahertz system at 0 wait states. You get pretty sizable performance increase on a system like that. You're running a 6 megahertz clock speed, but you're getting the performance of maybe a 9 megahertz computer. So you're actually exceeding the performance of even the 8 megahertz 5170. And then there's one final configuration, off and then on, where you get 7.17 megahertz. It's very odd clock speed, but that's what the system runs at. And that runs at 0 wait states. And that has the equivalent of around an 11 megahertz 5170. So you get a sizable performance increase by that configuration. And it appears that this motherboard fully supports that speed. Like, it doesn't have any issues with the RAM speed or anything like that running at that 0 wait state. The only problem that I found is that one of these machines had the -3 version of the math code processor. That's what I'm pointing to right here. And it really does not run properly at these higher speeds. It only runs properly at the 6 megahertz speed, because essentially the system will half the clock speed that goes to the math code processor, and that runs at 3 megahertz or something like that. And if you try to run it at 7.17 megahertz, it's actually overclocking, or 8 megahertz for that matter, overclocks the math code processor, and it will not work. All right, we're not quite done with the dip switches. Dip switch 4, I could not figure out what that one does. Doesn't seem to really have any noticeable difference when I switch it on or off. And the same goes for switch 8. And I thought that maybe was like disabling or enabling the floppy drive controller, but that does not seem to be the case. Either way, these just don't work. 5 and 6 seem to be something to do with the RAM size. So if it's off and off, it's the 1 megabyte configuration. I think if they're on and on, it's 512K and that's it. Like, the system will never work with more than 512K. And there maybe are some other configurations in there. But I did try the 640K setting on the jumper over here. What was it? Jumper number 3. And I tried fiddling with these, and never could I get any extended memory. So it really feels like this particular motherboard, if you have the 640K configuration, is expecting those 64K chips and other bank here. And there's no way to get that extended memory, or at least that 384K of extended memory. And then the final switch is 7, and I wrote must be on. If it's on, everything is working fine. If you turn it off, when I type on the keyboard, you get gibberish. So my assumption is that maybe this motherboard was designed maybe for like the Japanese market to support some kind of Japanese style keyboard that had different scan codes. It's not XT, because I tried an XT keyboard and that doesn't work either. It just doesn't seem to work properly. But when you set that to on, everything does then work properly. And that's all there really is to say about this motherboard. As I mentioned, all 3 of them work absolutely perfectly, and they're pretty fast. And when you set it for 7.17 megahertz at 0 wait states, it's really quite speedy. And for 1985, that's a big deal compared to what IBM was selling with the 5170 for probably substantially more money. And that would be running at 6 megahertz with 1 wait state. And yeah, this thing is basically blowing that computer out of the water, maybe almost twice the performance in that 0 wait state config. Pretty cool. Okay, the final machine is coming together. What I've installed in here is of the original serial parallel card. I have a video card temporarily in here. I'm going to put the EGA card into here so I can use a CGA/EGA monitor. I have both of the RAM expansion cards in here. So there's the AST RAM page and the Intel above board. This is a total of 2.5 megabytes of extended memory, plus that 640K that's on the motherboard with that dip switch set. And then I do have an MFM controller card in here. I have the big one installed in here, and the full height hard drive in here, which is working. I've also gone ahead and installed both of the black Mitsubishi 5¼ inch disk drives, because these are definitely the original drives that would have come in this computer. It's super duper unlikely that they ever offered a 3.5 inch for this machine, at least while this machine was being sold in 1985. Unfortunately, I've run into a little bit of a problem when using this MFM hard drive on this machine. I'm going to power up the computer here and I will show you what the problem is. So it takes a little bit of time to boot up the machine because it's counting up all of the memory. So that's the 640K plus the 2.5 megabytes of extended memory. And right now it's booting off the floppy drive. I have a 360K boot disk in there. Now, it goes without saying that machines like this need some kind of CMOS setup, and there is nothing in the BIOS to do that built in this machine. You have to run some kind of a DOS utility to do it. So I have G setup on this disk, which is my go-to program for doing these types of things on machines like this that do not have their own CMOS setup. I actually went ahead and installed new clock battery in here, and I used Ron's Computer Things little boards he sent me on a mail call episode to install 2 CR2032s in series, so we get about 6 volts, and there is a diode on that board already, so those are not getting charged by the motherboard, which means this thing retains all of its CMOS settings when you power it off and power it back on. And you can see there I have some time and date stuff entered in, along with the base memory 640K and the 3.5 megabytes of extended memory. And I do have the math code processor installed in this computer. I have the -8 version, so this thing is running at that 7.17 megahertz with 0 wait states and the math coprocessor, but we have a problem. I need to go to number 4 here for the hard drive C so I can configure this MFM hard drive. And when you do, it comes up here and it says press right or left arrow to select a hard drive type. And in fact, there is some even help to tell you that that is what you need to do. But unfortunately, when I push left or right, it just beeps. There is absolutely nothing I can do to set anything in there. My assumption is the BIOS that's on this computer must be somehow incompatible with G setup, and there's no way for me to configure the MFM hard drive in here. So at this point, I'm totally stuck. There's no way for me to configure this MFM hard drive, not unless I probably swap out the BIOS with a different type. But to retain the originality of this machine and run the Mitsubishi BIOS, I can't do this unless I have the original setup disks that came with this computer. And let's be honest, I can't even find a mention of the MP-2400L on the internet, let alone documentation or setup disks. So I think at that point, well, there's really nothing I can do for this, and I'm just gonna unplug it, leave it in here, and for further demonstration, I'm just gonna put the XT IDE in here. And yeah, that's kind of lame, but that's what we're gonna have to do. We'll take a look at that. The machine is finally back together the way it would have looked coming out of the factory. Other than the fact the front panel's a little bit yellowed. This is the less yellowed of the two that I had. There are some scratches on the cover, the top cover and the plastic here. Obviously these machines were banged around and sort of mistreated before they got to me. But overall, cleaned up really well. Looks really good. And yeah, with that big hard drive still in there, it's a very, very heavy machine. Let me get a monitor hooked up to this thing. Let's see it in operation. And there we have it. It's like the Chonk Master 2000 has entered the room. Yeah, look at the size of that large keyboard compared to the computer. It's kind of like dwarfing it a little bit, and the 14-inch 1084 monitor, well, looks kind of puny sitting on top there. Let's power this thing on. Of course, this computer comes from an era where you just needed one fan and it was loud and blew a lot of air, and that kept the whole thing nice and cool. It takes a moment to boot up. RAM R is the conventional memory being tested, the first 640K, and then RAM P is the extended memory, which this machine has 3.5 megabytes, so it takes a little bit of time. Let's run Speed 600 on here and let's look at how fast this thing is actually going. So it's currently set for 7 megahertz or 7167 megahertz. At 0 wait states, gives us the equivalent speed of around almost 11 megahertz. We have the math coprocessor, which is still running at half speed, well, thereabouts, I don't know, 7.43 megahertz. And the video speed, well, it's slow because this is an EGA card, and EGA, it's always slow. As a comparison, I booted up my 5170. It is overclocked to 8.9 megahertz, and the CPU speed here in landmark speed test on the 5170 is 9.8 megahertz. Meanwhile, this is getting 10.8 megahertz. So this overclocked machine isn't even as fast as this one, running at 7.167 megahertz. Let's try Planet X3 in EGA mode. You can hear how loud the speaker is. Yeah, it's a pretty loud speaker. It actually vibrates the entire front of the machine, which is kind of cool. And yeah, I mean, this thing performs, well, exactly like you'd expect a 286 to perform, which is pretty good. And I mean, considering this only came out a few years after the original PC and then the PC XT, processor was a giant step forward over those machines. And there you can see how much memory this thing has. So that 640K of conventional, well, 639 for some reason. And then the extended memory, 3,584K for a total of 4,223 kilobytes. Awesome. And then we're looking at the Chonk Master versus its grandfather right there, the IBM PC5170. It's pretty good. I think the styling on the IBM is a little nicer, especially because of the painted front. No yellowing or anything like that. And it's so large compared to that thing. But I guess bigger is better, and your money paid for a giant heavy machine that's definitely much heavier than the IBM. So there you go. And frankly, I cannot deny the good quality build on this thing. All 3 power supplies worked, all 3 motherboards worked, all the components worked, all the RAM worked, everything just worked, even those original floppy drives there. Just pretty damn awesome. Boy, I really need to do something about this reflective material on the walls here. It really bothers me how bright that is from the studio lights there. Anyhow, it's time for a conclusion. I'm pretty impressed by this machine. The Leading Edge MP-2400L, it's somehow unknown to the internet, and yet quite a nice machine. Really nice machine. I would love to hear from any of my viewers who remember this machine. Either you had one yourself or you saw them in stores or something, because I'm just so surprised again that there's just no information about this machine anywhere on the internet. Kind of goes back to that video I did where I looked at all those weird cards and stuff and how so much of that stuff is just, there's just nothing, no information. And we have an entire computer here from a company that sold lots of computers and yet nothing. Anyhow, if someone in the future is watching this because they found one of these and they were looking for information on those dip switches, for instance, well, hopefully the information I showed in this video can help you out. And I do have to add one thing as well. Anytime I work on 286 era machines, especially ones that are early examples of that like this, or my 5170 right behind me, it's a pain in the butt. These things are just difficult to work with, and I think it's mainly because they don't have that built-in BIOS. And it's just buggy and freezes and weird things happen, and that G-Setup program is just so difficult to use. There's so many issues you run into. It just makes everything you do on this thing take that much longer. So I've alluded to this in the video several times, but I've been working on this video for a long time. I started before I went to VCF Midwest, and it's just been a non-stop endeavor to try to get the hard drives working and the cards tested and all the other parts. And while it was long, at least it's gratifying to have one really nice, clean machine out of this. And in fact, I'm pointing over there. You can't see it in the big mess over there, but there's the other machine, that second one, that can be assembled into a fully complete machine. Although it's gonna have beige disk drives because I stole its black disk drive for this machine, but it will be assembled, and I already have someone I'm giving that machine to who said he's been looking for a 286 machine for a while now. So there you go. Anyhow, I hope you enjoyed this video about this unknown machine. Definitely comment down below if you have thoughts about this machine and all that good stuff. Huge thanks to my patrons. Their names are scrolling up the side of the screen over here. If you want to see your name there or at the beginning of this video, you can do so at the link in the description below. My patrons get early access to videos, plus behind the scenes content. I do little weekly updates, and I've even done a live stream already that's exclusive to my $4 up tier on Patreon. I guess that's going to be that. So if you like this video, thumbs up. If you didn't, you know what to do. And stay healthy, stay safe, and I'll see you next time. Bye-bye.